Welcome to a living LED lighting lab in Croton's Town Hall. This is Croton's Town Hall. My name is Lindsay, Audin. I'm the chair of the Croton Sustainability Committee. I've been doing lighting for many years. I did Columbia University. I did a bunch of other places, commercial buildings, industrial buildings, etc. I've done over 20 million square feet of lighting. So I was very interested in being able to do this project, and fortunately, NYSERDA, thank you very much, gave us $50,000 to do the upgrade of lighting in this building if we would bring it out and show it to other people. And this is part of that, bringing it out and showing it to other people. Okay, now why do we bother with this? What's the whole point? You want to cut the cost of lighting, you want to cut the kilowatt hours, and you want to cut the carbon. That's the main thing. We all know that when power plants work, they emit carbon unless they're nuclear or renewables. So the point here is that we can convert indoor lighting and we can change it from the standard fluorescent. This is a T8 lamp. Who here can tell me what the 8 stands for in T8? 1/8 of an inch, exactly. So a T12, the old style, is 12 inches, 12/8 of an inch, so it's 1.5 inches in diameter. All of these are the things that look pretty much the same aren't. This is using mercury to make the light. Put power in here, little electrodes, send out a little arc. The arc takes mercury inside, vaporizes it, which creates ultraviolet light. The ultraviolet light shines onto the phosphors, which is a compound that's like fuzzy inside here. They glow, and that's what gives you the light. In all of these others, there are LEDs inside. You should be able to see them. Can you see the little yellow things? Okay. Those are LEDs, light-emitting diodes. Only in this one are they fully visible. In all the others, there is some form of diffuser, which is not phosphors. All the phosphors are built into the LEDs. The way this process works is that when they put electricity in here, it goes to circuit boards. Those circuit boards put out through the LEDs ultraviolet light, which then hits the inside of each LED, hits phosphors on the LEDs, and converts that into visible light. So that's enough of the high technology stuff. The main point here is we want to cut the energy bills, and especially if we can cut the carbon footprint. Now, part of the problem on this, and I've run into this with many people, is they can't figure out which one to choose. There are 10 varieties here. This is only a little piece of the market. Overall, I found about 45 or 50 different brands and different types. While all these look the same, there are 3 distinct types among these. We'll go over that in a little while. It can be a challenge to a lot of people. So the deal is, which are you going to choose? These things are all called tubular LED lamps, or TLEDs for short, or TLED. So you can see in the picture, there are all different kinds. This is from a DOE study that they did. Many of these old ones here that have odd look to them, like this flat one, they didn't even make them anymore. You will find that about 1/3 of all the tubular LED devices that have been put out are out of business and gone. It's been a very rapid turnover. A couple of the ones we were going to put in, we couldn't because the companies went out of business. These are all major companies that hopefully are going to stay in business for at least a few years. The question comes though, what about using, instead of these, retrofit kits? Those 2 big things at the end and the one right next to that blue box, which we call a driver, those are retrofit kits. They change the entire fixture. Instead of it looking the same, it looks different. These are all retrofit kits. These are what are called flat plate kits. That's the one on the far left. We'll get to them in a minute. But the question is, do you want to spend the money on a retrofit kit, which costs more, or just put in some of these cheap guys? These typically cost anywhere between about first I'll do it for a single lamp. These cost anywhere between $8 and about $37 per lamp. These are all 3-lamp fixtures. So we start with 90 watts from what was here before in a 3-lamp T8 fixture, and it goes down to about 39 to 50 watts depending upon which choices you make. That's for the 3 lamps together or for one of the retrofit kits. If you got the money, the ideal thing to do is to buy brand new fixtures because they come with all kinds of interesting doodads built in. The ability to dim, the ability to sense people's motion, all kinds of stuff. That's very pricey. You don't do that unless you got a lot of money. We put in only 7 of those. Those are in the stairwells. They dim down. They don't go off. They dim down when nobody's in the stairwell. Then they come back to full as soon as somebody walks into the space. So you've got several choices to do that depending upon your budget. The cheapest are these TLEDs. You can get by with about $8 to $10 per lamp depending upon the brand that you buy. So multiply that times the number of lamps per fixture, you got your cost for equipment. However, one of the big findings of this study was that the labor cost can be significantly different based upon some of these because some of them require rewiring. Now, in our lighting lab, what we did was we took a corridor upstairs, a 2nd floor corridor, and we put in 10 varieties, 3 of the retrofit kits and 7 of the TLEDs. They're going to look very similar, except the ones at the far end, which have the retrofit kits. And we will show you how to look and see what the differences are and how to measure those kinds of differences. And in the corridors, as I say, in the stairwells here, these have the what are called Lamar automatic dimming fixtures. They turn themselves down when there's nobody around. Okay, now, to relight this building, and why did we choose it? This is the largest electric load for a building in Croton. The only other large loads we have to do with pumping water and street lighting. The street lighting has already been converted to LED. The pumping stations is a whole other McGill. It's all big motors, no lighting involved. This was a place we could grab the most kilowatt hours very quickly. This building was put up in 1909 and was repurposed into a village of offices in 1939. Then, shortly thereafter, they put in T12 lamps. These are the old style, 1.5 inch diameter, magnetically ballasted, inefficient lamps. Then, in the 1990s, all that was converted, through the help of the New York Power Authority, to these T8 lamps. Originally, the old T12s for each fixture pulled about 135 watts. These T8 lamps, with what's called an electronic ballast, a device that takes power from the line and converts it into what can be used by a lamp, that dropped that wattage per fixture down to 90. We are taking that down now to 39. So you can see the huge drop, and it's all the same light output or essentially the same light distribution. We're bringing this old building into the 21st century in essence. And here, bottom line, is what this will do. It's going to cut the electric bill by $12,000 a year. It's going to save about 76,000 kilowatt hours. It's going to cut out 16.3 tons of carbon per year. It's going to cut out about 16 kilowatts of load off the grid, lower the building's cooling load, and if they're all telling the truth about how long these things last, they will make it so we don't have to relamp for 15 to 20 years. Normally, with these types of old lamps, T8 lamps, you got to relamp about every 5 to 8 years, depending upon how long they stay on. So we're cutting the relamping by half or more as well. Thank you very much to NYSERDA for putting up the money. We really appreciate it. Now let's move on. I'm going to use terms here. I'm going to assume most of you know a lot of these terms. If you don't, we'll bring them up and we'll go through them as we do the class. If any of these are brand new to you and you need me to define what is a lumen or whatever, just raise your hand, we'll do that. Otherwise, I'm going to assume you know a lot of this stuff. Otherwise, why would you come here? Because you have an interest in lighting, obviously. The one thing I will tell you that's different that you do need to know are what we call the type A, B, and C, A, B, and AC. All the rest of this stuff is standard lighting lingo. This is the new lingo that goes with TLEDs. A type A lamp is what we call a plug and play. It means you can pop out a T8 fluorescent, pop one of these in, and you're done. It works in the same with the same ballast and the same sockets. That's it, you're done. That's real cheap on labor. However, it will continue to use the same ballast. Once the ballast conks out, you've got to go and replace it. Type B, that's one of these guys, the type B, they have the ability to take power straight from the line, 120 volts, right into the lamp. You bypass the ballast completely. In doing so, you have to rewire around the ballast. Type C, which is way down at the other end, I'll show you in a little while. Type C, once again, you are going to bypass the ballast, but you're going to install, see that blue box right there, the little square long box, that's called the driver. You're going to install a driver in there which is designed to operate the lamps at ideal temperature and ideal operating. Type C will save you slightly more in wattage, but the difference among most of these is very small on the wattage. So almost any one of these you put in, you're going to save a bundle as far as the wattage goes. All the rest of these things, these characteristics here, I'll discuss them as we go along. Page 2 and page 3 of your brochure, which looks like this. Page 2 and page 3 of this describes each of these things in more detail. So if I'm going along and I say lumen and you forgot what a lumen is, go to pages 2 and 3 and it has all that stuff laid out for you. Now, here's the bottom line we came up with on this whole discussion. And in case you have to leave real early, this is the thing you want to listen for. Hold on while I catch up here. All 7 types of the tubular LED lamps we tested yielded roughly similar results. Not all of them yielded the same results, but enough for the average person, they look about the same. The labor and the lamp costs, that's what affected the return on investment and the life cycle cost. We found that sometimes there were differences in the what's called efficacy, that's lumens per watt. Little differences. Those are small, those differences, compared to the difference in the cost of the device, I'll get to you in a second, and the cost of the labor. Yeah?
Similar results in their appearance. And everything else, or just?
The appearance, the distribution, you'll see when we go upstairs, there are some what we call lighting artifacts, where there are lines on the wall, which is a result of whether or not there is a diffuse surface or a visible LED surface. On the task, when we look at the table, that's where we do our work, that's called the task. Most of the time people take foot candle levels on the task because that's where people work. One of the other things about our building was that we had fixtures that you will see that are very close to the wall create a scalloping effect. That was the existing condition. Some of these exacerbate the scalloping effect. You'll see that upstairs also. It's something very difficult to shoot in a picture, and you'll see my pictures show the scalloping, but you won't be able to see that difference until we get upstairs. Now, there are various testing organizations that have now pretty much set the certifications for these different kinds of lamps. US DOE and Designer Lights Consortium, hereinafter known as DLC, they pretty much standardize a lot of this stuff so that other characteristics like power factor, total harmonic distortion, CRI, a lot of those are all the same now, so you don't have to worry about those things. L70, by the way, in case I forget to mention it, is the point at which the lamps have lost 30% of their light output. LEDs hardly ever burn out, unless you make a mistake, and which I did, and I'll tell you about that one later. We burned out a bunch of these. But they normally never burn out. What they do instead is they lose their light output. When they're at 70% of their light output, that's the L70 number. That's usually hours in lifetime, and that might be 50,000, 80,000 hours. Usually a fixture is on about 2,500 to 3,000 hours a year. So at 50,000 hours, you're talking about 16 years from now, these things will have dimmed down enough where it might make sense to change them again. Long time ahead. Instead, we found that the issues you really want to look at have to do with very much nuts and bolts stuff. Look at the fixture, look at its ballast, what type it is, and the lamp holders. Hold on a second. I think I have some here. All right. Do I have them here? If not, I'll pull them up. A lamp holder looks like a little tombstone. I'll find them. Here we go, this one over here. I don't want to get caught up in any wires. One of these comes with tombstones. Yeah, here we go. This device here, these are called lamp sockets. They call them tombstones because they look like little tiny tombstones, okay? Those differ as well. You'll find that some fixtures have what we call shunted tombstones. Some have unshunted. We're going to show you a picture in a minute. Those characteristics, what kind of ballast you have, which may have to be compatible with the type A unit you put in, and the type of lamp holder may make a difference. And there's also interactions between the LED lamps and the type of fixture based upon how hot the fixture gets. So those are some of the first characteristics you want to look at. Others that you want to be taken care of have to do with the beam spread. None of the TLEDs put out light circumferentially. You'll see a picture in a few seconds, but the idea is that while this lamp puts out light in all directions, almost all of them shine down. And the width of that shining down is what we call beam angle or beam spread. Yeah, we're going to give that in a minute. But the deal is that the type of fixture you have may influence whether or not you want to put some of these in because it may narrow the beam spread enough to make it an issue. You also want to look at the cost of the labor to put them in and the cost of the lamp. Those things may make a bigger difference than the efficiency, the efficacy of the individual tubular LED. Yeah?
Is there a concern about cold temperatures?
These things love the cold. Originally, they were designed to work in refrigerated cases because unlike fluorescent lamps, which like to live at 77 degrees, that's their own temperature, if you heat them too much, less light comes out. They'll also use fewer watts. If you make them really cold, less light will come out or they won't come on at all. These are pretty much insensitive to temperature. You can run them 30 degrees below zero all the way up to 150 degrees. Last big job I did was for a refrigerated warehouse where a lot of the space is frozen, because it's all in meat packing. We put in all new LED fixtures there, worked like a charm. Whereas before, some of these guys just didn't punch out the light the way they should have. So outdoors, perfect as well. Yeah. Yeah, in this we had 3 lamp fixtures. Well, put it this way, if we were replacing lamps as versus kits, we took out lamps and put the same number back in. The deal we wanted to do was to find which of these was very similar to the existing T8s. And that way we chose the wattage out, the lumen output and the wattage based upon trying to duplicate just what we had before, so that in the fixtures that are not kits, like you see out in the corridor, the parabolic louvered, will look the same to everybody, so nobody will know the difference. Some of them noticed, but most of them didn't notice it. In some cases, if you want to, you can take out, if you've got a 3-lamp fixture, you can take out the one in the middle and buy 2 tubular LEDs that are 16 or 17 watts each, and that will cut down the number of lamps you have to put in, though it may change the distribution. But yes, there are different wattages and different light outputs even of the TLEDs. Okay, if you've got the money, buy retrofit kits. Thank you to NYSERDA for giving us enough money where 70% of our space has retrofit kits. They give better light distribution, and they also have other ameliorative, better characteristics. If you're real rich, buy new fixtures. They're even better. They do all kinds of fancy stuff for you. So how do we save the energy? How do we save the money? Okay, this is when we get into beam spread and things. First thing they do is the actual LED takes in the wattage and produces more lumens. A lumen is a measure of light output. The more lumens you have, the brighter the lamp is. They can put out more lumens for each watt. So therefore, right off the bat, they're more efficient than a standard fluorescent. But they also, as I say, narrow the light distribution. Now we're going to talk about that, because this is one of the big bugaboos with TLEDs. This is known as a candela distribution curve. I won't say that again. It's the curve. If you have a fluorescent lamp, it's sticking like this right out of the screen, it puts out light relatively equally. These are angles around the circumference, the radial diagram. So at this point here, it's putting out 100% light. Here it's 100%. There it's like 90%. So the further out you go to hit the line, that's how bright the light is at all these different angles. But oh, look at our friends, the TLEDs. You've got narrow, medium, and wide. This orange line that you see here, that is what we call your beam angle. At that point, right at this angle here, like 105 degrees between them, this is 50% of the maximum light output down at the bottom. So here, in only 105 degrees, he's putting out all of his light in a narrow space. This guy more, this guy more. The yellow covers not just the 50%, but any other light that's coming out. On both of these, what's called the aperture, or beam spread. This is called beam angle. These guys are beam angles. This whole thing here is beam spread. The deal here is that when it's a wider distribution, you've got a wider beam angle, you also have a wide beam spread. See the yellow? That's indicating that light is still coming out partially upward. Always best to shoot for a wider beam spread if you can get away with it. It will tend to mimic the existing fixture output more. But that's one of the ways that they save on wattage, is that they actually don't put all the light out in all directions. They wham it way down so you got lots of light level on the task. That can sometimes make walls or vertical surfaces look dark. They produce fewer lumens. Hold on today. We're still connected. Good. Just give me 1 second. They produce fewer lumens, but they tend to concentrate them further onto the task. In many cases, that's fine. We're going to compare the options. This is the corridor that you're going to go into after. We're going to show you before in a few seconds. The retrofits are arranged so that a viewer can look down the hallway and you can see the differences in them. Again, I'll have to point some of these out to you because they're fairly subtle. The 8-page brochure has, in the back, a table 1 through 10. When you go down to the hallway, you'll see signs 1 through 10 also hang off of each fixture. That way you can see which one is which. Without something like this, you're going to say, hey, Lindsay, 7 of them are just all alike. They all look the same to me. Well, not quite. Here's the big differences we want to focus on. Difference in equipment cost, labor time to install, that beam angle and spread, and the task light level. In most cases, the task light level will be pretty close to where you started from, 40, 50-foot candles. That's about what you need for doing most work. But you will find big differences in the cost of equipment and in the cost of the labor. You've already got a copy of these. Anybody who doesn't have one, you can get one at the village manager's office, which is right there. That's room 24 on the 2nd floor if they have extra copies. In the stairwells, we put in bi-level LED fixtures with built-in motion sensors, and they turn the lights down. They don't turn them all the way off. We're originally going to put in motion sensors in a lot of the spaces, and we concluded after seeing the behavior and the operations of the building that there were only a few places where motion sensors to turn the lights off when there's nobody around, that they made any sense. But I will show you what we're going to put in. These are combination ultrasonic and infrared sensors. They fit into a standard light switch, and these will replace the ones in the bathrooms because that's where the lights stay on all the time. And they have a sensor in them such that they will sense motion, And the type we're going to put in here, this is more technical and this is more interesting. One of the big problems with motion sensors is it costs a lot to install them unless you are putting them right into an existing switch. If you've got a big room, one of these may not see everybody in the room. This will. This is a type of technology we call N-Ocean. It's a device by which you can put it in anywhere, has no batteries. It uses light coming out of the windows and out of the fixtures going into solar cells to power itself. You can put this a good distance away. This goes into the light switch. It sends signals back and forth electronically without using any electricity because they have built into them either the ability to collect electricity and make it through the solar panels or through a device called a piezoelectric quartz circuit where if you just touch this a little bit, it creates enough energy in doing so that it sends a radio signal out to this. No batteries, doesn't use any power at all. The mere fact of you putting the finger like that makes enough electricity to send the signal out. Okay, moving right along. Here's the difference in color. This is before and after. Here's before, there's after. I assume you can see the difference, right? Now, the color of the lamps in what's called K, that's the color temperature, was the same for these. This was 4100 K, this is 44,000 K. The difference of 100 K the human eye can't see. But even though they have the same color rendering index, which is a way to say how well they are characterizing surfaces that you see, while the color rendering index is the same, in LEDs that you buy in kits or TLEDs, they do not have the same way of putting out color as standard light fixtures and even fluorescence. Why is that? The characteristic is called color rendering index. Color rendering index is a standardized way to look at 15 different colors. In the measure of the index that's used for standard lighting, they look at only the first 8 of those 15. Number 9 is a certain color called red, R9. Because R9 is not required to be considered in LED lamps, they don't have much R9. So as a result, you're going to have high color rendering, you're going to have high same color temperature, but you're going to have less red. These are actually slightly green in the walls. They come out looking slightly blue. If it's all done the same way, nobody's going to notice. But if you're lighting something like clothing or skin or anything else that has need for looking good in a store, you may not want to use these kinds of things. There are better units you can buy. In your, where have I got it? In your LED comic book, here we go. You look on the, hold on. Right, page 3, it shows you the impact of different kinds of LEDs. These are only available in fixtures. I know of no kit, I know of no tubular LED that will give you the difference in quality that you can get by specifying different kinds of LEDs. Those are very expensive. So if you're going to do a food market or a clothing store or something, you may want to put in new fixtures and specify, as they say here, either Artist Series, Vibrant Series, Beauty Series, whatever. That's on page 7, page 7. By the way, thank you to Zicato. I promised I would do them a free commercial. Zicato provided these comic books for free. They make very good, high-level LED stuff, including this kind of device, which is used to even more carefully control light output and color, which goes in behind the ballast, little tiny thing. They also provided the comic books and something else you're going to get for free a little later. There, that's the end of that commercial. Okay, now, it takes about a week or two for the eye to adapt and the mind to adapt to the new condition. But one of the things I want to draw your attention to, and this is very subtle. Look on the floor here, look here. You see these slightly increased dark patterns? That is due to the beam spread being narrower on the TLEDs than they were on the standard lamps. It's not a big deal, but it's one of the things that you will see, and as you get into doing lighting work, your eye will get more conditioned to look for those kinds of details. As I say, once all the fixtures are the same, nobody will notice a difference. Now, the other differences are fairly subtle. Now, when we go upstairs, I'm going to go through this slide real quick, but when we get upstairs, we'll go into more detail. Units that have visible LEDs like this, they create, as you'll see upstairs, artifacts, lines on the wall. And if there's anything that can be reflected, and you see I'll have tilted a picture on a wall up, they create a distraction because if you have any kind of bright surface, what we call specular, like a piece of glass or glass screen, these will show up. They look like a whole bunch of little dots, and they draw the eye to them. So I really don't like these. However, if you want to go see one installed, you can go to Robbins Pharmacy, which is about half a mile from here, where they put in exactly this kind. Now, Greta, come on in, come on in. This is also another entrance to the building, so we'll have people traipsing through every now and then. No problem. The idea being that the more visible the LEDs are, the more distracting they are. That's why I don't suggest using these. But they're also, in some cases, the cheapest. That's what people put in. Now, there can also be glare. Let me march down here for a second. In number 9, this is number 9 that we're looking at. This is a computer screen, which I put on a little table, and I ran it down the hallway to see if anybody got glare. The only one that showed up glare on the computer screen was this particular type of retrofit kit. All of the LEDs, all the lighting is inside this tube. And you'll see it right away when you go upstairs. This is fairly bright. All the others were sufficiently diffused so that you did not see any kind of glare on the screen. Of course, a lot of people use computer screens nowadays, so you don't want glare on the screen. Just go ahead through. Go through. Walk through, please do. Walk through and around. Thank you. With a light meter, we are going to measure, and I brought one with me to show you the differences in the light level on the floor and at the task. We also have what's called a flicker wheel. Now, this is an ancient flicker wheel. This goes back about 25 years ago. It's turned yellow. I'm going to ask you to come up here now. I'm going to share a little test on this while we have other people traipsing through here. Yeah, come, just pass through. Just pass through. All right, now. Okay. This is an old T8 lamp on a magnetic ballast. Now, do you see any flicker?
Not by the naked eye.
Okay. Now, flicker wheel, developed many, many years ago. Do you see the pattern on the wheel? Okay. That is flicker at 120 cycles, 120 hertz, cycles per second. That's what you don't want. That kind of thing can create headaches for people who have something called photoepilepsy or worse, and with some autistic children, it can cause behavioral problems. It's not the kind of thing you want in an institutional public building. So we unfortunately found that 4 out of the 10 devices that we installed had excessive flicker. We'll talk about that in a few minutes. And also in your comic book, when you get to page 11, I'll just open that up for you here, there is a chart. This chart describes for you how you can avoid flicker. One of the other reasons why this occurs is that just like with the R9, it's not required in TLEDs. Likewise, there is no flicker standard for any of these tubular LEDs. As a matter of fact, there's no flicker for any LEDs. There is a standard which is discussed here and also on the, one of the slides called IEEE 1789-2015, which if you specify it means that these things will not flicker more than 10% at a couple of hundred hertz. That way it'll avoid the problem. Yeah?
So these don't flicker?
These don't flicker because these don't even have AC power. These are all DC powered lamps. So there's absolutely zero flicker.
Can you show us the wheel with the no flicker?
Should be able to. Hold on a second. Right over here. Here we go. No patterns. Now, one of the ways you can check also a more highfalutin device is called a ballast discriminator. These are created in order to figure out which fixtures had old T12 magnetic ballasts, which did flicker, and ones that didn't. So normally what you do is you take this and point it right at the light, and the little light goes on, but then it stays off completely. That means there's zero flicker at all. Normally what you'd get is green. I'll just plug this guy back on again. All right, let's see if I can do this now. Okay, it shows up red. Red means you've got 120 cycle flicker. But you'll see it first comes on. Nope, it's not going to show you green at all. When it's green, and we'll take this upstairs, it means you're good. It means there's some flicker, but it is not something that's detectable at 120 cycles, so it won't get in your way. Okay, go back and sit down now.
No, it's such a simple matter. They need to add a capacitor to these ones. That have
Well, what we ended up doing was with the 4 that we had flicker in them, and they were, sit down there, you. 2 of the different types of TLEDs had flicker, and also, much to my astonishment, one of the kits made by a company called Redbird